Hi everyone, this is Duke with a video here on how to build your wee tiny freestyler in the FPV class, fall of 2024. So I'm making this video to update my instructions. We have different electronics this time than last time, and I also had written instructions last time, and I thought I'd make a video. So this is meant to help you assemble your quadcopter physically, and I have another video I made previously for setting up the software with Betaflight. So we're using Ryan Rogers' wee tiny freestyler frame, which is a 3-inch frame. Works really well. I've really liked it the past 3 or 4 semesters we've taught this class, and it seems very durable, easy layout. I like the frame. Plus, I think it's really cool because Ryan is a local guy here, and it's kind of cool to have something designed by someone locally. So what we want to do here in this video is I'm going to start with some kind of notes for you because Ryan has a great video where he assembles the frame, and you can use his video to put this together. But there's a couple of things in his video that are more open because he has his frame set up in a way that's configurable for a variety of electronics. I'm going to address those things right now because we already know our specific electronics we're using. Okay, so that when you're going through his video, you go, oh yeah, Duke said to do it this way out of the options that Ryan has available. Okay, so I'll do a few notes here. I'll send you over to Ryan's video, and then you'll come back here to finish the electronics with me, if that makes sense. Okay, so the first thing I want to point out to you is the screws here. Okay, let's zoom in a little bit. All right, so these 4 screws that are sticking up through the bottom of the frame. Now Ryan has his frame set up so you can do different layouts. Okay, there are holes for 30 by 30 mounting. There's 20 by 20, which is where the screws are at, and there's 16 by 16. Those numbers just refer to the distance between each hole. Okay, there's also 25.5 by 25.5 at a 45 degree to the others because that would be like an all-in-one or whoop type flight control board. Okay, so we're gonna use a 20 by 20. Okay, so just realize when you're putting the screws into the bottom plate, as he talks about in the video, you want to put them in the 20 by 20 holes. Okay. Another thing that is specific to our build is that we're going to use screws that are 20 millimeters long. Okay, by default. Those will come in your SpeedyBee electronics. So in here, let's see, under the accessories area, we have the M3 category of parts there. And where did I put the M2 is over here. Sorry, took that out earlier. And the M2 section here. And we're not using M3. You can save that for another project or something. But the M2 is what we're going to use. There are 2 sets of long screws in here. One of them are 20 millimeters long, and one other set is 25 millimeters long. The 20 millimeter long screws work great with our kind of standard class build. If you're going to add an HD FPV system like Walksnail or DJI or something like that, you're going to have to make some changes to the standard build, which may mean you want to use the 25 millimeter long screws, or even longer potentially, depending on your setup. Okay, there's not a lot of lateral space to grow things on the quad, so everything kind of has to go in the middle. And so if you have a different video transmitter, like a digital one, compared to our analog that we're using in class, you may need to just make the quad taller, essentially, to fit everything in there. And you might want to consider using the 25 millimeter screws. Okay. 25 millimeter screws will fit with the rest of the standard build. Okay. This pink thing here is called a standoff, and that basically determines the height the top plate is from the bottom plate. Okay, so with the stock standoffs, which are these black ones, let's see where they go. Yours aren't pink, but they're black. Same thing though. Okay, with those stock ones, the longer screws will fit. But if you go over 25 millimeters in length of the screw, you'll have to buy different standoffs that are actually taller than the stock ones. Okay, so that's one note. You're going to use those screws when you install them into the bottom plate, which Ryan does in his video. Okay. The other kind of companion to this is how we install them. Okay. I don't recall, I haven't watched Ryan's video recently. I don't recall if he does this or not, but you can see I have the screws going up through the bottom plate and I have a nut right here holding the screws so they're not just kind of flopping around in the plate. They're tightened down. Okay. Sometimes that's called the golden nut. It's just a nut that's installed to keep the screws nice and rigid, helps with a lot of vibrations and things on the quad, makes it basically fly better overall. People do sometimes omit that nut. They don't put it in, and they just use the nut that goes on top of all the electronics to kind of sandwich everything together. That generally leads to poorer flight performance, so I'm having you all put the nuts on the screws on the bottom. Okay. We will also use metal M2 nuts in class. The M2 set here comes with some plastic ones. I don't really like those, so I'm having you guys use metal ones. Okay, so these are all metal M2 nuts here. All right. And that leads us into the discussion on how we attach screws and stuff to the quad. Ryan does not use Loctite in his video, and that's everyone can kind of choose, but in class I would like you guys to use Loctite on all of your hardware. All right. So when you're putting this nut onto the screw, as you thread it down a little bit, you want to thread it, 3/4 of the way or so. Get your Loctite out, put a little bit of Loctite on the threads, and then finish tightening the nut down so it goes through the Loctite and get some Loctite on its threads to tighten it down and keep it from coming loose. That would be a huge pain if it came loose. You have to take the X piece off at a minimum, which means the arms are kind of going to come off typically. Well, not all the way, but you got to take the X piece off at a minimum to get to the back side of these screws if you needed to tighten something down again. So you want to Loctite those. Also, other screws that you assemble for the frame, you should Loctite. Okay. Now, you want to build the frame basically to this point. You don't need to put the top plate on and stuff yet because we haven't done electronics. You want to build the frame to this point following Ryan's video. Okay. And then you'll come back and I'll talk about electronics in a minute. But anything you assemble in this bottom section here should be Loctited. Okay. As an example, I had to Loctite a typical screw. Okay, one that just goes straight into the frame. Okay, a little bit different than the nuts up here. I'll show you. We'll just grab our screw, grab some Loctite. Okay, this is the blue Loctite removable type. We're going to just apply a little bit of Loctite to the end of the thread of the screw, the part that's going to be into the frame press nut. Stuff comes out pretty fast. I'm trying to get it all over the table. Yeah, that's a little bit too much even, but see that little bit there? I'm going to wipe some of it off with my finger. I don't need that much. Okay. Then I'll go ahead and put it back into the frame. Okay. You notice I already have the frame assembled, and now I'm putting Loctite on stuff and putting it back in. Whenever you're doing that, I find it easiest to assemble something first, especially with these arms, so they're held in place, and then I just pull one screw out, put Loctite on it, put it back in. Pull it out, Loctite, back in. Go around the circle there. It just helps, I think, to do that because then it's not trying to hold everything and keep it in place with your hands in, put the Loctite on and screw it in without getting Loctite all over the place and getting frustrated. So those are some of the notes I have as far as the frame assembly. So I think that's it. We'll do the electronics, like I said, when you come back from watching Ryan's video. This is the general rule. Remember, 20 by 20 mounting pattern, 20 millimeter long screws if you're going to do the standard build. Okay, and don't forget the Loctite. All right. So at this point, you want to pause the video, this video, go watch Ryan's frame assembly video, and then come back and finish this up. All right. So now you're back from assembling the frame with Ryan's video, and we're going to talk about electronics and how they physically attach to the aircraft and everything. So we'll start kind of in the middle here with the stack, right? And your Speedy B stack comes like this, as you've probably already seen. You have two components here. Okay, your ESC, or your electronic speed controller, and your flight controller, or also known as your FC. Okay. These are going to go on these 4 screws. Okay. And I'm going to assemble everything here, kind of modeling how you would solder it. I'm not going to do any soldering right now. I need to save these components for another build. Okay. But I'm going to kind of model it out here for you so you can see where you're going to attach things. Okay. So this yellow part here being the front of the drone, here's our electronic speed controller mounted there. You can see that with those little gummies, it doesn't touch the carbon or anything. Carbon is conductive, so that's good. It's not touching. And this is basically the power distribution of our aircraft. Battery power is going to come in the back here, and it's going to be distributed to the 4 motors. And that's how our drone is going to fly, essentially, in terms of power. The other component here is the flight controller. This will go right on top of the ESC. Okay, and this is why they call it a stack. We're stacking the things on top of each other. We get this onto the screws, so it's finicky. There we go. Okay, so we'll see our stack's going to look like that. There we go. Okay, and so that's where the 2 components will go. We obviously need to do some wiring, but this is where they'll be located. And with those 20 millimeter screws, there's enough thread here to grab another nut and put it right on top and compress the stack a little bit. That'll be just about perfect to hold everything together. And that will allow us to have plenty of space. We don't need the screws to be longer than that. unless you're doing something else where you need to stack another component on top of these. Okay, the standard class build, we will not need that. So let's take the flight controller back off for a second. Okay. With your SpeedyBee kit as well, you also receive a little bag of goodies like this. Okay, it's in the bottom of the box under the accessories tab. Okay. You have some different harnesses here. This longer harness you won't need. We don't use that for anything in class. So you just leave that in the bag, whatever you want to do with it. We will use, though, these other three components. And as you can see, I've been fiddling around the capacitor already. It's usually not that bent, but that's okay. So we have a battery lead, a capacitor, and a wiring harness that goes between our flight controller and our ESC. These need to be connected in order for the flight controller, the brains of the operation, to give the ESC signals to tell it how fast to spin the motors and which motor to spin. Okay. So let's start with this one though. Actually with the capacitor probably. We'll start with the capacitor. So the capacitor goes here on the back on the battery terminals. We talked about it in class a little bit, but capacitors help smooth out voltage so there's no big spikes, or at least not as big of spikes that damage components from our battery. And so that's what this is for. We're going to zoom in a little bit more here. You can see on the capacitor we have a negative side, which is also the shorter of the two legs. Okay, we want to make sure we put that in the right section on our ESC, the right pad here. So they have those nice little holes already kind of pre-installed for us on these two battery pads. Do this a couple ways. You can bring the capacitor in rather close and just bend it over like so. Okay, and solder that on. Okay, make sure you solder those in place, and then trim the extra excess off the bottom so it's nice and flat or flush. Okay, or alternatively, if you don't want to have the capacitor sticking right there, right back in the center like that, you can make the leads a little bit longer. I'm going to bend this back here, and you kind of bring it off to the side. Okay, the idea being, if I can get this back on here, it's always a battle to get these holes lined up for some reason. There we go. The idea being here, if we bring it off to the side and bend those under a little bit. Okay, again, you'd trim those bottom ones off after you soldered it. We kind of measure it out here so that we would have a way to keep the capacitor off to the side. Sorry, keep the capacitor off to the side. Run a zip tie around the capacitor and kind of hold it in place so it's not vibrating or causing any excess noise, electrical noise or anything like that on the aircraft. Oh, I messed up the gummy. Whoops. That's my bad. Didn't actually get it through there on that one. There we go. That's better. Okay. So you can bring it back and strap it on here. And sorry, not electrical noise, but any other vibrational noise on the aircraft. You could zip tie that down and have those leads be a little bit longer. Okay. The trade-off here is basically comes when we install our other component onto the battery leads here, which is the pigtail itself, the battery pigtail where you're going to plug your battery into later. Okay. This gets installed into the TPU mount here that goes in the back of the drone. So you can see on this one, the battery plug is right there, the video transmitter antenna is right there. This is installed in the back of the drone by putting the screws and standoffs through it. Okay, so we'll eventually get to that. When you're building the frame, you'll see that part as well. But we want to make sure we thread this through first. Okay, it is directional, so the 3D print has a curved side and a flat side, just like the actual connector itself does. Okay, so we'll thread that through there. That's meant to kind of suck in and push in there a little bit. I'm just going to leave a little bit of it hanging out so I can remove it again later since I got to take this back apart. But like so, okay. This is going to be mounted roughly about here where those back two holes are, okay. And so if you put the capacitor off to the side, you may find it a little bit easier to run your cables up to the battery pads here from the connector, just kind of straight in. If that makes sense. You'll need to trim these; they're going to be too long, anyways. But you can run it more straight in, okay. Whereas if the capacitor is in the center, like we had it earlier, okay, it's going to effectively block some of the ability for you to put the battery cables straight in. And you're going to have to kind of go around the capacitor somehow. And you do have to reverse these. Unfortunately, this direction of the connector forces it to be negative on the left and positive on the right. but the ESC has negative on the right and positive on the left. So just make sure you look at the signs there, plus and minus. You got to cross these over though. Okay. And then you're going to go ahead and attach them like going around the capacitor like so, or something like that to that effect. Okay. You might have to do something like that if you have the capacitor coming straight out. It's up to you. And honestly, you could also, if you really wanted to, mount the ESC upside down. Okay. And then have the battery leads come straight kind of that way over the ESC. There are a number of different configurations you can use, but I'm trying to explain a few of them so you can get a feel for what you're going for here and make your decision on how you want to route things. Okay, so that's our capacitor attached there, whether it's short or a little bit longer off to the side. And then we need to attach our battery lead, like I mentioned. You need to cut this down to a shorter length, tin the wires and tin the pads and everything and attach it there. And that will give us basically our battery power into our ESC. Okay. The next step of our powertrain is the motor's attachment to the ESC. Okay. You can see I have one motor attached here already. So let's take a look at how we did that. Okay. With our motor, it gets attached to the arm. You can see the holes here. There's 4 holes for the screws and 1 hole in the center for the motor shaft. It kind of protrudes a little bit. And we'll take this one off. Okay, there's that protrusion on the bottom there that sticks in that center hole. Okay. So we'll do that. Attach the motor like so to the arm along with this yellow bumper thing. Now some of you may have the arm kind of skid protectors that go on the edge out here. I'm not using those in the video because not all the kits have those. It depends on which prints we got and that kind of thing. But if you have those, you can obviously slip those over the arm as well and put the yellow thing on top of those. Okay, which is kind of how this one is set up. We have the yellow skid, the TPU kind of protective piece here, and then the carbon. A student printed these out for me a couple years ago when we were doing that build, so that's why they're on there. Okay. But an important part about attaching the motors is which screws you use. Okay. And in the video, the frame video, Ryan mentions that the M2x6 screws are for the motors. It varies motor to motor and things like that. And M2x6 screws, in my opinion, are a little bit too long. They go up too far into the motor, get too close to the copper coils in there, which will damage the motor. Okay, with these particular motors. Not all motors are the same, right? But with these motors and the thickness of this attachment plate right here, M2x6s are too long, so we can't use those for these motors. Luckily, however, the motors you have ship with 5, which is kind of crazy, 5 different sizes of screws for use with the motors and the propellers. Okay, and I went through and measured these, and we have some M2x4s, M2x5, M2x6. Okay, and so what works really well is instead of using the M2x6s, whether it's from the motor kit or the frame kit, is actually if you use the M2x5s. They're a little bit shorter and they work really well. Okay, let's get these back up. So grab the M2x5s, which will be the second to smallest bag of screws in each motor package. Okay. Grab one of those. All right. And take the yellow piece here. This is how I double check motor screw length basically. I'll put the screw on here. Run it through all the stuff I'm going to run it through. So in this case, the skid plate and the carbon arm. We can see how far it sticks out there. Right now it's going to be hard to see on camera, but if you then take your motor and just lay it over the edge, okay, without getting the shaft in the way, the motor shaft in the way, okay, you can kind of begin, let's see if we can zoom in and get any better. There we go. You can begin to see maybe what I'm doing here. I'm just trying to see how far, was I screw this in, how far is it going to stick out, and how far do I want it to stick out to get through that motor plate. So you can see as we put those next to each other, they're essentially the same height, almost exactly. And to me, that's just about perfect. It doesn't go too far into the motor. We know it's going far enough because it's just about the same height as the motor mount piece. Okay, so I'm going to use M2x5 screws to mount my motors. When you mount the motors, you want to make sure that the shaft again is in that center hole, and then the 4 screw holes line up, and your motor wires should travel back in the direction along the arm. They shouldn't stick out, a different way. So let's go ahead and put this together. And kind of get it snug enough it's not going to fall off. You don't need to tighten it down all the way yet because we've got to line up the other 4 screws as well. So we'll make sure that's getting to be nice and flush. We're not stuck on the motor shaft, not being in the hole or something. And we have 1 screw in, so we'll make sure the other ones get lined up with both the plastic piece and the carbon and the motor, and then we'll put the other 3 screws in. Then again, you want to take them out one by one and put Loctite on each screw and put it back in so the motor is Loctited in place. These, I mean, there's vibrations on quadcopters all the time, and if you don't put Loctite on these, uh, in my opinion, there's a pretty good chance that they'll loosen up during flight. And in my last semester teaching this class, we actually had a student who didn't put Loctite on, and the motor nearly fell off after a few flights. And he didn't, barely noticed in time, basically, before the motor came off. So I'm not saying that'll happen to everyone, but in my opinion, you should use Loctite on motor screws. So we'll do that and attach the motor that way. Okay. Once you have a motor attached, then you of course go and do the other 3, right? Same way. And we have our motor wires, which are plenty long, which is nice. We don't have to worry about lengthening wires, which is kind of a pain. They're plenty long. Each motor is going to need to reach to the ESC in its corresponding position. Okay. So there are 6 pads on each side, 6 solder pads, 3 for the back and 3 for the front. Okay. So your motor wires should reach along the arm, here, and not be pulled taut. You don't want the motor wires like that. It's too tight. Okay. Give yourself a little bit of slack, kind of run your finger along the wires, and then make sure they're going to be long enough when you cut them that you can attach them to the pads there. Maybe something like that in terms of length. You can put a zip tie around the arm to hold the wires in place so they don't get up in the air and get cut up by the propellers. Okay. But you don't need a ton of slack because that's really hard to manage and not get cut by the props. You don't want it to be too short because then it can cause problems with actually, damaging the wires, and also it's just hard to solder. Okay. So each motor will go into its corresponding position with the wires and be soldered in place. So here, 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 and here. And then your ESC and motors are soldered up and ready to go. Okay. So that takes care of basically the powertrain essentially of the quad. We have the battery lead back here. Okay. Let's scoot that up a little bit. Battery lead back here. The motors are attached to the ESC. It's all connected together. Okay. And that's great. With the next step here, we have the flight controller and ESC. Okay. And we notice they have this little plug on both of those. Okay. And we have this little harness that comes with our kit or our electronics. And this is meant to connect the flight controller to the ESC. Okay. When you're doing these plugs, make sure that you're not forcing anything. You should get the pins and the plug to line up with the ones on the flight controller ESC. It's going to be kind of on the top or on the bottom, right? The pins are not perfectly centered. They're offset. And if we look at both the flight controller and ESC, we can see on the side of the connectors, so on this side, let's see if we get that close enough. There's some small lettering or numbering here. We have a minus, plus, 1, 2, 3, 4, CN. The flight controller is labeled a little bit differently, but similar. Yeah. We have a GV12 and then a 3, 4, CT. Okay. Those are all different, basically abbreviations for what these wires are doing. Okay, so this should work out of the box. It's from the same manufacturer. They give it to us as a set, so it should work. But just in case, we can double check things by making sure if we plug it in the right way, making sure the pins are aligned. In this case, we're going to have the pins kind of towards the camera more. It should slide in, and then use your fingernails to kind of press it all the way in so it seats properly. Okay. And if we say, okay, let's look at that again, we have our minus, plus, 1, 2, and here we have black and then red. That's kind of the standard color for negative and then positive, so minus and then plus. So that's, generally speaking, it should be incorrectly, right? These other wires, of course, could be out of sorts or something, but they shouldn't be since it's from the manufacturer. But that wouldn't do any damage if we plugged it in backwards per se. If you had the positive and negative out of order or in a different spot, that could damage components permanently. So we don't want to make sure we don't do that. The other side of the stack has the same type of connector here, so we'll install that. Okay. It goes in this orientation per the pins. We can double check the orientation, okay, via those little numbers there and letters. So instead of saying plus minus, it has a G and then a V, so ground and then voltage or power, and then again 1, 2, 3, 4, and we have a C and a T here, which correspond to the C on the ESC as well. So that is our stack wired together. Okay. When we put it on the drone, this will be on the bottom, this will be on the top. Okay. You can leave it like that. It does kind of stick out a bit. A lot of wires right there. You can kind of tuck it over to the side if you want. Or alternatively, you could try twisting it maybe once. Okay. Maybe I twist that twice. Let's see. No, just like that. There we go. Okay, so like a full 360. Get the wires in a little bit more of a bundle. You don't want to twist it too many times and damage the wires or put extra stress on them, but that helps keep it a little bit tidier, closer to the boards themselves, which is nice to give us more space on the frame. Okay, and there's our stack. Right. So let's bring the frame back over. So we're going to let this sit down here on our screws. There we go. And then we have our stack installed on the quad. Everything's got good clearance, not in the way or anything. Looks good. Okay. And we just give a little more space here so we can more easily fit our camera up in the front, perhaps. All right. So that is the stack and motor wiring. Okay. And next we're going to kind of get the extra stuff with the camera, the video transmitter, the receiver, and we'll jump into that next. All right. So, well, the next few steps, I'm going to be going back and forth between the document camera and SpeedyB's website, which is where they have the product manual for this flight controller. You should also be able to get to it with the little QR code thing that comes with the electronics, so you can scan that or just find the website. Either way is fine. Let's turn that on real quick. Okay. I have the weird OBS thing so I can show you guys my mouse pointer. So if we go up to the top here, let's go back to regular size. So I'll show you where I'm at. Let's go back to SpeedyB. There we go. Okay, so SpeedyB's main website is here. They sell a number of different products, kind of all related to drones or cameras or things like that. Okay, let's make sure this is recording. Okay. But we're going to go here to Products, Stack, and then go to our 20 by 20 stack over here on the right-hand side. F405 Mini BLS 20 by 20. Okay, click on that one. And that's the page I was just on before we went back. So if you scroll in here, they got a lot of pictures and stuff. I'm actually going to zoom out a little bit so we can find everything easier. Get down past all the pictures and stuff here. We get to some actual specifications and a wiring diagram. Okay. You'll want to reference this as you go through the build. I'm going to walk through it here with you, but I would recommend you reference it. You can even print it out. Sometimes it's nice to have a physical thing to look at when you're building so you don't have to go back and forth the computer a bunch of times. But here is a wiring diagram for the flight controller. Okay. You also see down here we have a wiring diagram for the flight controller to ESC, which we just did. That little harness we plugged in between the two boards is what we just did there. So that's there as well. And you can see the motor wiring here and the capacitor and the power cable here as well. So basically that's what we did already. And now we're going to focus on this last step here with the flight controller. Okay, this is a little more complex since they have multiple options you can connect. Okay, but in our class, and I think all of you are using an Express LRS receiver. Okay, it's the one up here in the upper right hand corner. And that's the first thing we're going to talk about wiring up is the receiver. Okay, so you'll need to supply your own receiver for the class. So you might have a different model than what I'm going to show you on camera, but Express LRS receivers of all types are pretty much wired the same in many ways. So we're going to just go with that generically. Okay. You'll see on the receiver here it has 4 solder pads is what these are representing here. RX, TX, 5 volt, and ground. Okay. Those 4 solder pads are going to be connected to wires, which will then connect to the flight controller. Okay. And if you follow the wires down, you'll see that they go right here to the upper right-hand corner of the board where we have a ground or G, 4V5 or power. Then we have an R2 and a T2. Okay. So ground and 5 volts, or ground and power, just go straight down to ground and 4V5, which is almost 5 volts and turns on when you plug in with USB. So that's nice to have our receiver power up on USB only, not just battery power. But those two wires will go down there, ground and 5 volt to the ground and 4v5 pads. Okay. The tricky part is not that tricky, but you got to make sure that you wire your TX on your receiver to the R2 or receive pad on the flight controller, and your receive or RX pad on the receiver goes down to the T2 or transmit pad on the flight controller. So we go TX to R and RX to T. Okay, and that's so that the flight controller and receiver can talk back and forth with each other on those two wires. One talks, the other receives. One talks, the other receives, and if that makes sense, vice versa. Okay. So if we go over to our actual flight controller, okay, this is hard to see on the dot cam, but up here in the front, so this is the front of the drone, we have our T2, R2, 4v5, and ground, those 4 pads right there, where we're going to attach our receiver. Okay, in this case, this receiver has it nicely labeled as well. We have a ground, 5 volt TX and RX, so we know where those go now on the flight controller. The last thing you want to think about is how long to make your wires. Okay. You don't always really want to have wires going right over the top of the flight controller if you can help it. So, I mean, you could do that, but you could also run the wires underneath the entire stack and have them come out the front and wrap around. Typically, at least when I built these, I have the receiver in the back here, and I zip tie it again in place on the other side here around this little loop. I zip tie the receiver in place, I have the wires go around, come up, and solder right here. You could mount the receiver in other positions as well. You could experiment or see where you like it best. But try to avoid having wires going directly over the flight controller or directly under it if you can at all help it. Okay, so those 4 wires will give you connection between your receiver and your flight controller and will also power your receiver. Okay. All right, next up is our camera. Okay, let's grab our camera out here. There we go. Okay. So the camera is a Caddx Ant. Comes in a box like this. Okay. It comes with a couple different cables. Comes with this little board, this little piece here, this green and black cable, and then the one I have plugged in here, this red, yellow, and black cable. Okay. Right now I have the camera attached to one of the standoffs, or one of the mounts for the front of the drone, so we'll talk about that in a second. But on the back of the camera we have 5 different pins in 2 different plugs. So we have a 3-pin and a 2-pin on the right hand side. The 2-pin is for this black and green cable and for this little joystick pad thing. Okay, you can use this to adjust camera settings in the terms of like white exposure and color saturation and stuff like that on the camera if you so choose to do so. I've never really messed with those on any camera that I've used. I don't have a ton of experience with different FPV cameras, but I've never needed to mess with those. If you do want to use them, you can, and this is how you would configure those once the camera is powered from the flight controller. But we're not going to fly with this installed, so we'll set it aside for now. We don't need this mount. This is to make the camera effectively larger. Okay, it just goes around the camera for mounting in a larger quadcopter, but we're not doing that, so we don't need that piece. All we really need is the camera, the cables, and then there's a handful of screws that come with the camera. Okay, oops, let me zoom out a little bit. That are used for attaching the camera to the drone. Okay, so you can see here what I've done is I actually took this whole standoff off the quadcopter, but you'll notice this yellow piece and this purple piece go in the front here. Now yours will be the same color, I just have different ones I'm testing. Okay, they'll go in the front here, and these pink standoffs get screwed into the frame. Okay, so they stay in place like the yellow one is right now. Your standoffs will be black. I just have different colored ones here. What we do to attach the camera to the drone is we're going to attach it physically using some of the screws that come with the camera. You just want to find a screw that has a good length. Okay, they can go through the 3D print and protrude a little bit. Okay, which will allow it to screw right into the side of the camera where the screw holes are at right there. Okay, one on each side. You can mount that right now, or you can mount it after you do the wiring. Either way is fine, but just to show you how this works. Okay, I'm going to tighten the screw down. I'm going to kind of snug it down. I don't need to wrench on it, but get it nice and snug. And then once this is installed, okay, the other side will get screwed in as well. And so it'll kind of pinch the camera in between those two 3D printed pieces, which will keep it in place, both, not having it tilted left or right, but also keeping the camera at the angle in which you put it at. So it's not tilting up or down while you're flying. It should stay in a fixed position and just be able to see out from there, if that makes sense. Okay. You notice I use the front holes. There is a small hole in the back on the prints and then a larger kind of slot hole on the front. The front one works well, I found, and you don't get too much of the 3D printed stuff in your camera view, which is nice. You just see what's in front of the drone. You could move the camera back slightly if you wanted to, maybe get a little more protection from hitting stuff in the front of the quad, though I haven't had a problem with that. Okay, either hole works just fine. That's the physical mounting of the camera into those TPU 3D printed parts. And then we talk about the wiring. Okay, so we have this harness here with 3 wires. I'm going to tell you right now it's power, ground, and video signal. Okay, let's flip over to the diagram on the website and look at that. Okay, so we'll zoom out here on our wiring diagram. We're going to zoom back in on this RunCam Model Phoenix 2, which is a camera. Okay, you'll see it has 5 pins in the back, a group of 3 and a group of 2, just like our camera. And we can see the red, black, and yellow here. Okay, you can see this blue one as well. You can do some of those camera settings through your flight controller if you want to. You can wire it up that way like that blue wire is. I'm not going to worry about having you guys do that in class. I don't think it's super necessary, but you can do that if you'd like. That should allow you to control some of those camera specific settings from your flight controller. But what we're going to focus on is the red wire here going from the camera to 5 volts, the black wire going from ground to ground, and the video going from video to the cam pad. Okay. So in our instance here, look at our flight controller closely. Okay, we have top 5V, ground, and cam. So those 3 pads right there. Excuse me. The 3 ones we talked about, and the 3 wires come out of the harness, okay, to be cut to length and soldered onto the flight controller. Leave yourself a little bit of slack. It doesn't need to be tight. Again, nothing needs to be tight, but you don't need to like cut it way down here and have, that much slack. That's too much. You don't need that much. Okay. So attach those front 3 there. And that will wire up your camera to give it both power and allow a video signal to come from the camera into the flight controller. We'll talk about the second half of that signal next. Okay, so the second half of that signal, our video signal is going to come in from the camera, go into the flight controller, and it's going to go to the video transmitter. So why is it going in through the flight controller, right? The reason why is because the flight controller has what's called an on-screen display chip built into it. And so the video signal can come in, the flight controller can take information about the drone, like battery level, altitude, position of your control sticks, your throttle or something like that. Okay, take all that information, it can overlay it on top of the video as an on-screen display, and it can then send it back to the video transmitter to be transmitted out to your goggles. That's why I run it through the flight controller. You could connect the camera directly to the video transmitter and you get video just fine. You just wouldn't get any on-screen display. So that's the reason why we do that. So our camera's wired up. We talked about our receiver already. The other, I guess, external device we have is a video transmitter. Okay, and yours will look like this most likely. Okay, this Beta FPV board that comes in here. Unless we have more enrollment, we won't have to grab any other ones. We do have some other ones that are a slightly different brand. It's just hard to get enough of these of all the same kind sometimes for class. We'll focus on this one though everything would be wired very similarly for the other video transmitter. So if you end up with a different one, ask questions of course, but I'll talk to this one right now in this video. Okay, so this is the Beta FPV. What's the name of this one? The MO3 VTX. Okay, it's a very small video transmitter, but it does go up to a decent power level, especially for a 3-inch quadcopter. We're not going to be flying super far away from ourselves. Okay, and you can see here on the back we have a small stock antenna that's attached to the board, and we have 4 pads here on the back of the board. Okay, so we're going to be doing a couple things. We're going to be soldering to the board and attaching the VTX to our flight controller. We're also going to be swapping out the antenna, the stock antenna, for a much better performing one, this bluish one here. It's kind of hard to see, this bluish antenna here. Okay, so let's flip over here to the web. All right, so here we are. Let's go to the web. On Beta FPV, we just searched for Beta FPV MO3, which was the name of our VTX. And here we're on their product page for the VTX that we have. And I actually made an error when I was showing you it a second ago, so we're going to correct that now. But they're not only the 4 pads on the one side with the antenna connector, okay? They're actually 5 pads. One's just underneath the antenna typically, so you can't see it unless you flip the board over, okay? And so we have these 5 pads here, and we need to wire these up to our flight controller, okay? We have a smart audio, which is the signal that can control the video transmitter's power and what channels it's on and things like that, what channel it transmits the video on, okay? So we'll use that. We're not going to use the cam pad in our instance, okay? That's for a different type of camera setup, which we're not using. So we are going to use the VTX pad, and then we use ground and 5 volts. And so we have those there laid out for us, and they are labeled on the top of the board. I just didn't realize we need to use the VTX pad instead of the cam pad. So smart audio, then VTX, then ground, and 5 volts. So we're going to go over to the SpeedyBee diagram here and zoom out for a second, give you orientation. Okay, we've got a receiver up here, a camera over here. Down here on the bottom right hand side we have an analog VTX, which is what we're using with the class build. Okay, and an analog VTX of this type will have, again, a power, ground, a signal. They say it's IRC here, which stands for IRC tramp. Basically it's a controlling signal, and then we have the video signal itself. It comes from the flight controller with the on-screen display overlay and then gets broadcast out to your goggles wirelessly. So corresponding pads for us, if we look at the Beta FPV one here, okay, 5 volt, ground, 5 volt and ground. IRC corresponds to the smart audio pin here, or pad. And then we have the video, okay, which corresponds to VTX right here. Okay, so again, we're leaving cam blank, right? So we're going to join those together. 5 volt over here to the 5 volt pad. Video or well, let's see, what was it called over here again? Video or a VTX, yeah, VTX on the VTX goes to VTX on the flight controller. We have ground, goes over here to this ground pad, and then we have IRC, or in our case, smart audio, that goes to T1. Okay. On our physical setup, we have those pads here along the bottom. So we have the 5 volt VTX, and then we have the ground and T1. Okay. If we have our board up here, we can see the labels for those on top, though the VTX pad is underneath the antenna, so you might want to solder on the bottom side. Just pay attention to the order of the pins. You know, it'll be reversed since it's upside down, if that makes sense. Okay. We'll have our smart audio, then our cam pad will get skipped. So we'll have smart audio, then skip, then VTX, then ground, I think. Let's see. Yeah. Then ground, and then 5 volts, and those will get wired to the flight controller. Sorry, it's a little bit out of frame there. To the flight controller. Okay. Physical wise, the plan for these VTXs is to have them wired up, install the upgraded antenna by feeding it through the TPU mount. Okay, so feed it through here and kind of down that little channel with the antenna captured here to keep it from getting damaged and ripped off. Okay, the antenna will come out the back, kind of like this one. See this little black cable there, comes out there, goes into the center of the drone. So the antenna will get fed through there, down through. It will come in and connect to the VTX. We'll take off the stock antenna by pulling straight up on that antenna connection once we've cut the heat shrink off right here. We can then attach our new antenna. Okay. And if we have the antenna coming out this side and all the wires coming out this side, it'll be very easy to put some heat shrink over the entire VTX and attach it to the bottom side of our top plate. Okay, so it'll attach to the bottom side with some double-sided tape. Okay, just like so. We'll then put our top plate on, just like that, on top of the drone. Okay. You will want to give yourself a little bit of slack on the wires because once it's like this, you need to be able to take this off to do any maintenance or things like that. You don't want to have to rip off the double-sided tape every time just to get the top plate off. So give yourself a little bit of slack on the wires so you can kind of take the top off and maybe put it to the side like this and still have it connected and everything. Okay. But just be aware that we'll kind of join the top plate to the rest of the drone by doing this. There could be other ways to mount this. You can experiment with other ways. That's just my initial thought, is to put it up here. This is a different video transmitter than we used last semester, so I haven't actually built a drone of this size with this one. You could stick it somewhere else potentially. I don't know exactly where you would put it, but you can think of other ideas if you'd like. Okay, so that's the wiring for our video transmitter to the flight controller, as well as the installation of our upgraded antenna. Okay. And with that, I think we're at our final stage here, which is propellers. Okay, we've done ESC, we've done flight controller, we've done motors, we've done camera, we've done receiver, we've done video transmitter. That's pretty much it. You can add other things like LEDs and GPS to your quadcopter. We don't do that in this class though. Just kind of do the basic build. And for propellers, I wanted to talk to you about that for a second. These motors are called T-mount motors. They do not have a threaded shaft. They just have a smooth motor shaft. Okay, so it sticks up there. And our props are designed for those by having these three holes. So the center hole is where the shaft goes, and the two outer holes are where you put some screws to hold the prop onto the motor. So we have 4 different holes here in the motor. It doesn't really matter. They have 4 of them, so it's easier to line it up, I guess. So we'll put the prop on and try to line up with the holes to make our job a little bit easier. Okay, just like that. Press it all the way down. It should be about flush. And then we bring back our 5 different bags of screws from our motor. Okay, these are the 5 bags of screws that came with each motor. And remember, we use the second to smallest ones to attach the motor to the arm. Okay, now we can pick the middle bag, or middle in size. Okay, or this is the same size as these ones. These are the same size screws. There's different colors. So basically, either of these two can be used to attach the props to the motor. Okay, and I think it's just an aesthetic thing, I guess, if you want to pick the silver ones or the black ones. Again, the way I figured out which ones would work best was I took the screw itself, put it on the screwdriver, and put it like this, and said, okay, coming down from the top of the prop here, check that focus, come on. And if they come down from the top of the prop, it should go through the entire prop and go into the motor a little bit, but not too far. And this is a great length. Okay, I think these are M2 by 8s, I think. Anyways, you get that lined up with the hole in the motor. You just screw it in. No, it's not lined up yet. There we go, maybe right there. Feel around for the screw holes a little bit sometimes, get it aligned. There we go. Okay, nice and snug. Goes in just like that, and you put the other screw in there, of course, and do that the same thing for all 4 motors. Okay. This is the one area where you don't use Loctite. If you use Loctite on prop screws or prop nuts, the Loctite will eat away at the plastic the props are made out of and cause the props to basically disintegrate over time. So we don't use Loctite on these. We just check these screws for our pre-flight and things like that. Make sure they're tight and ready to go so they don't come off when we're flying, of course. And that's how you install your propellers. Okay. So that should take care of the physical assembly of your aircraft. Now, you don't need to put the propellers on until you're all the way ready to fly. I just wanted to show you how in this video. You'll need to do some software configuration to make sure the propellers are going the right direction and stuff way before you ever put them on. So don't worry about that yet, but now you know how to put them on. The rest of the assembly should be covered in Ryan's frame assembly video, so you kind of go back and forth between his video and my video a little bit, I guess. But that should be fine, and that will give you your FPV drone. If you have any questions, please feel free to reach out and ask. Of course, I may have missed something in here or may have misspoke. I hope I didn't, but I think we got everything covered. Let me know if you have any questions, and happy building.